Good morning, happy Wednesday. I'm going to try this on white paper. I'm just trying to see if maybe you guys can read this a little bit better. Why don't you go ahead and press pause and copy down the top half of this, right, with the diamonds, the cubes. That's to the third power is cubed, and some integer problems. Okay, I'm going to move it up. And why don't you go ahead and copy down this bottom part, okay? And I will actually do a separate video explaining why I say watch out for the math police, and another way to remember when you divide with what we call a decimal outside the box is what I call it, okay? And it's basically when the bottom number of a fraction is a decimal, or the second number in a division problem like this is as a decimal. There's a special thing you need to do before you start. Okay, go ahead and copy that down. All right, now you want to go ahead and go see if you could do these, okay? And then come back if you get stuck or if you need some help, or hopefully to check your answers when you're done. Okay, see you in a bit. All right. Hopefully you did well on this. In making the diamonds yesterday and walking around the class, I realized that some of those were just way too hard for some kids. So I will try to make sure I have some easier ones so you guys who have not been doing the warm-up, and that's a key, right? These are easy for kids who've been doing the warm-up all year. If you haven't, then this is a struggle, right? It's not that you can't do it. It's when I work hard, life is easy. When I take it easy, life is hard. This is one of those situations where you took it easy when other kids were doing the warm-up, and now life's a little bit hard on some of these. So we're going to work hard so later on life becomes easy again, okay? All right, what two numbers have a product 25 and a sum of 10? Hopefully you figured out that that's going to be a 5 and a 5, right? 5 times 5 is 25. 5 plus 5 is 10. How about 35 and 12? Hopefully you recognize that is a basic fact of 7 times 5, and 7 plus 5 is 12. 56 and 15. And some people say, well, 9 plus 6 is 15, but 9 times 6 is 54. Okay. This actually ends up being 7 and 8. 7 times 8 is 56. 7 plus 8 is 50. How about 1 and 1/5 and 3 and 2/5? If you didn't get this, you're going to kick yourself. Check it out. 3 and 2/5. When I add 3 and 2/5, I get 3 and 2/5. When I multiply 3 and 2/5, remember, multiplying fractions is easy, but that's not a fraction. To make it a fraction, I'd have to put a 1 under it, which is fine. You can put a 1 under any whole number without changing its value. But now I have 3 times 2 on top, 1 times 5 on the bottom. 6 is improper. If I use 5 of those 6 to make one whole, I would have 6 minus 5, 1 left over. Not that hard, huh? 2 to the third power is not 6. It's 2 times 2 is 4 times 2 again. 4 times 2, 8. 3 to the third power. 3 times 3 is 9. 9 times 3, 27. 4 to the third power. 4 times 4 is 16. 16 times 4, 64. 5 to the third power. 5 times 5 is 25. Times 5. Don't go multiply it by 3 when you get done. 25 times 5, 125. 6 to the third power. 6 times 6 is 36, and 6 times 36 is 6/30s. Right, that's 180. 6 sixes, that's 36. 180 and 36. 6 cubed is 216. Now, 7 to the third power, you can do in your head. Right, that's 7 times 7 times 7. If I do this first, I have 49. Now, 49 times 7 is almost 50 times 7. How much less is it? Well, 7 times 1 less. 350 minus 7, 343. 8 to the third power. 8 times 8, 64, and 8 times 64 is 8/60s, 480. 8 fours is 32. This ends up being 512. 9 to the third power. 9 times 9 is 81, and you could do 9 times 81 in your head. Some of you, right? That's 9 80s and 9 1s. 9/80 is 720. 9/1 is 9. 729. And everybody can do 10 to the third power in the head if you know the rule, right? The trick with tens and powers is going to be a 1 with that many zeros. So it's the third power, it's 3 zeros. And that makes sense because 10 times 10 is 100, and 10 hundreds is 1,000. All right, integers. I have 8 plus I owe 4. I'm going to pay the 4 I owe and still have 8 or 4 left over. That's a positive 4. Now I owe 8 plus I have 4. I owe 8. I'm going to pay that 4 I have, but I will still owe 4, negative 4. Here I owe 9 and I have 3. I'm going to pay the 3. I'm still going to owe 6, not as much, right? Here I owe 9 plus I owe 3. Now I owe a total of 12. 12 minus 4. I have 12. I spend 4. Okay. Now I owe 12 and I spend 4. Now, this is where the advice, I didn't make up this advice. I was told this advice from former 6th grade students. They said, tell the kids, instead of subtracting, turn all of these problems into adding the opposite. Okay? All the problems turn into adding the opposite. Right? 12 minus 4 is the same as 12 plus negative 4. Well, negative 12 minus 4 is the same as negative 12 plus negative 4. Negative 16. And that kind of makes sense. I started at negative 12 and I spent 4 more. Now I owe 16. Okay? 10 plus negative 3. I owe 3, but I have 10. I'm going to pay the 3 I owe, still have 7. And I know what you're thinking. Well, why don't I just do 10 minus 3 is 7? Well, you set up this habit, and then all these hard ones become easy. This easy one gets a little harder. You do a little more work there, right? But all those hard ones become easy, and that's our goal. Okay? Negative 10 minus 3. I owe 10, and I go spend 3. How about I owe 10 plus I owe 3. I owe 13. Okay? How many of those did you get right? All right. 12 over 2 is the same as 12 divided by 2. And when we go do this with the standard algorithm, we put the 2, what I say is called outside the box. Okay. Now, Ms. Teichman has a great way of remembering this. Okay. 12 over 2. Let's write that on the back real quick. She says what you do is you give it a big karate kick. Kick it and knock it over. When you knock it over, it ends up falling down like that. Well, and then just put a line. Okay, so I'm saying 2 goes into 12. How many times? 6 times. So you kick over that fraction to make it a division problem. I always have just said divide the bottom into the top. But that's kind of a good visual way. If you could picture giving a karate kick, having it fall over, the line's going to be there. Then you just put a line on top. So that fraction line. Okay, why am I doing all this? Because I want to show you that division problems with decimals outside the box, like 3/10 into 25 and 2/10, right? This is just like 25 and 2/10 over 3/10, right? You kick it over, right? And that 25 and 2/10 lands over here, the 3/10 out here. Now, if you had this fraction, you could multiply this fraction by the magic 1 of 10 over 10, right? And then the decimal moves over one spot here, and you get 252 over 3. Okay? So that's one way of visualizing how we're getting rid of the decimal outside the box. But however many spots I move it here, right, is like multiplied by 10, right? I have to do the same thing on the top. So you end up, when you do that, it's like multiplying it by 1, which is not going to change its value. So when you're doing these division problems, okay, and you can't have a decimal outside the box and you have to move it over, if you move it over one spot outside, you move it over one spot inside. If you move it over two spots outside, you got to move it over two spots inside. If you move it over three spots outside, you have to move it over three spots inside. Okay. Now, if you want to watch a little video that I tell a little story to help you remember why, if you move, you have one scoop here, one scoop here, two scoops here, two scoops here, three scoops here, three scoops here, the same amount of scoops outside and inside. I'll tell you a little funny story to help you remember that if you watch my second video. Okay. Until then, you're just going to remember if I go one spot outside, I got to go one spot inside. I go two outside, I go two inside. Okay. So, the other thing I want you to do after you have moved this over, right? And now I have four decimals and all these scoops, it's kind of confusing. Spend about 5 seconds, and you could time me here, okay, and rewrite your problem so it's so much less confusing. So instead of dividing like that, I'm going to rewrite this. What do I have now? I got the decimal here. It's 3 into 252. And now I can divide. This is so much simpler and less confusing than this. So spend that extra 5 seconds rewriting the problem. Okay. Now 3 goes into 25 8 times. 3 times 8 is 24. What do I do now? I subtract. After I subtract, what do I do? Bring down the next number. And then 3 goes into 12 4 times, because 4 times 3 is 12. And I'm done. Okay. All right. To start this problem, watch out for the math police. If you start dividing with a decimal outside the box, you're breaking the math laws, and you will hear this woo, 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 and the math police will come and get you, and you don't want that. They're scary. Okay? So before I start, I say I got to get rid of this decimal. How do I get rid of this decimal? Well, I got to move it over two spots, because remember, if it's on the right, you don't need it anymore. However, I moved it two spots outside the box. I got to go two spots inside the box. Okay, what do I do here? Fill the egg cart. Now, do not start dividing with 4 scoops and 4 decimals. That is a confusing problem. Time yourself. This should take about 5 seconds. Rewrite the problem. Boom. Now I have an easy problem. 5 goes into 16 3 times. 3 times 5 is 15. Subtract. What do I do now? Bring down the next number. 5 goes into 18 3 times. 3 times 5 is 15. What do I do now? Subtract. When I'm done subtracting, what do I do? Bring down the next number. And 5 goes into 36 times. And that's an even fit. Boom, I'm done. 336. All right? All right. Ready to start dividing? No. If you start dividing, you're going to hear this woo, 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 woo. Math police will come and get you. You don't want that, right? So in order to prevent the math police coming arrest me for breaking the math law, I have to get rid of this decimal outside the box. No, you can't just cover it up and pretend it's not there. You have to move it over until it's to the right. And here I got to go 1, 2, 3 scoops, 3 spots outside the box. I better go 3 spots inside the box. Now, I don't see a decimal. What do I do? Well, if you don't see it, remember the whole reason we're putting it over here is then we don't need it. So I got to go 3 spots inside. 1, 2, 3. What do I do here? I know it's past Easter, but put those eggs in there. Okay, now you going to start dividing? No, that's too confusing. You're going to spend how much time? About 5 seconds rewriting your problem. 2 into 8,000. Okay. 2 goes into 8 4 times. That's a perfect fit. So I can keep saying 2 goes into this 0 times and 2 times 0 is 0, right? But I know if it goes into 8 4 times, it's going to go to 8,000 4,000 times. Boom, you're done. Okay. Now, this was written differently. Okay. Remember, when it's written like this, the first number goes inside the box. However, what if I just want to say I want to get rid of this decimal? I can move this one over one spot and this one over one spot and then rewrite my problem. 42 divided by 7. And now you know the answer is 6. Okay. 54 hundredths divided by 6 hundredths. If I'm going to move this over 2 spots, I can move this over 2 spots. Remember, it has to be the same amount. I can't go 2 scoops here and 3 scoops here. Okay, I can rewrite my problem. 54 divided by 6 equals 9. All right. Again, if you want a funny story to remind you why you have to do the same number of scoops each time, check out that other video. It won't be too long. Okay. All right. Have a great asynchronous Wednesday. I know it can't be great because you're going to miss your teachers, but hey, make it as great as you can. Okay. All right. Have a good one, everybody. We will see you on Aloha Thursday.